Okay, section 12.5 here, all we are going to do is summarize the quadratic forms and their relation to their graphs, or as everyone should know by this point, their parabolas. We just went over standard form and vertex form and intercept form, and we talked about all the different things that we could extract from those forms. What we didn't do is look directly at those forms next to a parabola so that we could more visually see how the parts of each form relate to the parabola itself. And that's what we're going to do here. We are going to look at the three forms one last time, and we are going to see how when we look at a parabola, we can actually see parts of each form on the parabola. So once again, standard form, I'm going to write y here, although remember y could be written as f of x. That would be perfectly fine. Y equals x squared plus bx plus c is standard form. Vertex form, we are going to do y equals a parentheses x minus h squared plus k. And for intercept form, we are going to do y equals a times x minus p and x minus q. So those are the three forms. Now, in terms of these parabolas that we have over here to the right, what we're going to do is for point A, we're going to write down that, of course, those are our x-intercepts. Might be a nice note to write down that, recall that x-intercepts are synonymous with the zeros. I'll just write zeros there. That's a zero. X-intercepts are synonymous with the zeros of the function, the zeros of the quadratic. And remember that your x-intercepts are from intercept form p comma 0 and q comma 0. Now obviously p could be greater or q could be greater, but one of these two intercepts is going to be p comma 0 and the other is going to be q comma 0. In terms of point B, which we should be able to see is on the y-axis, so that is the y-intercept. The y-intercept, remember, we can get from standard form. Standard form gives us the y-intercept because when x is 0, these two terms go away. 1, 2, they go away, and we get that y equals c. So when x equals 0, y equals c. So of course, point B right there is the point 0 comma c. We can see the y-intercept in standard form. Let me get rid of those cross-offs there. Point C and point D, those are both vertices, so I'm going to write vertex and vertex. However, recall that C is a minimum and D is a maximum. And the way that we know whether we are dealing with a minimum or a maximum is minimum will be when a is greater than 0, and the maximum will be when a is less than 0, and that a comes from any of these forms, okay? And recall that your vertex in either case, this is probably the most important thing, your vertex is h comma k, that is from vertex form. So whatever is in this h position here, whatever is in this k position here, those values in those positions will be the x and the y coordinate at the vertex, whether that vertex be a minimum or a maximum. And then, of course, that dotted vertical line that goes through each of those vertices, the minimum or the maximum, that is your axis of symmetry. And the equation for the axis of symmetry is simply x equals h. In other words, x just equals, along that vertical line, x equals the value of the x coordinate at the vertex of symmetry. All of the x coordinates of all of the points on that vertical line will also be h. Do want to reiterate the point that, I'll write this note down over here, remember that h can actually be found in multiple ways from some of these other forms. Remember that we said that the axis of symmetry could also be found from standard form by doing negative b over 2a. So we could find that h value, which is the x value at the vertex, and also the axis of symmetry, the x value at the axis of symmetry. We could find that h value by doing negative b over 2a from standard form. We could also find that h value from intercept form by taking the average of the zeros. Remember that that axis of symmetry must occur at the midpoint between the two zeros. Midpoint is exactly the same as average, so if we average the two zeros, the p and the q, we will get our h value. So this h can be found by using some of the coefficients or constants from the other forms. So again, in looking at these forms and looking at the c and looking at the h and the k and looking at the p and the q and looking at the a, we can tell some things about the parabola simply by looking at the forms. In other words, we wouldn't necessarily have to graph the parabola. We wouldn't necessarily need to convert the forms to other forms. There are certain parts of each quadratic form that tell us exactly where these key points are on the parabola. We're going to take a look at one question. There is some room at the bottom of the page, so if you want to jot these notes down at the bottom of the page, that's perfectly fine. This question is not contained in the manual. This question over here is not the most common type of question in the world, but it does show up every couple of tests. You'll see a question like this. If you want to take a stab at this question on your own, by all means, go ahead. I'm going to go ahead and do it now. Which of the following equivalent forms of the function f of x equals whatever is the most suitable to indicate the x coordinates of the x-intercepts of the graph of y equals f of x in the xy plane? So most suitable to indicate x coordinates of x-intercepts. So here's the thing about these questions. Yes, you could, if this were in the calculator section, you could try to graph this function. You could try to take this function and try to find the zeros either by factoring or by using some of the information that we talked about in terms of extracting information from standard form. That's what this is. However, the easiest way to do a question like this is simply to understand that there is only one form of a quadratic that reveals the x coordinates of the x-intercepts, and that is intercept form. And the beauty of this question, and many others like it, is that only one of these answers is in pure intercept form. Answer choice A is simply standard form with the 4 factored out. Okay, we've just taken the 4 out of all of these terms. Answer choice B, indeed, is intercept form. There's your A, there's your P, there's your Q, and we have said that P and Q are the x-coordinates of the x-intercepts. And in terms of answer choice C, this does look like intercept form a little bit, but we did talk about this in the section. This would be called more appropriately factored form. This is not pure intercept form. We can see 2 linear factors here, but we can see that the coefficient in front of this x right here is not 1, and therefore the number in this position over here is no longer the 0 or x-intercept. That is the same as in answer choice D. Again, these are both factored form. Now keep in mind, the question itself did say these are all equivalent forms of this function. In other words, all of these, when we manipulate them, let's say FOIL them out or distribute them, we're going to get 4x² plus 4x minus 24. So they all are the same function. But again, only answer choice B is most suitable for giving us the x coordinates of the x-intercepts of the graph of f of x, which is obviously a parabola because this is a quadratic. We will know that the coordinates of the x-intercepts are going to be 2 and -3. 2, which is the opposite of this, and -3, which is the opposite of this. So again, answer choice B is the only answer in pure intercept form. If there were 2 answers in pure intercept form, that technically could not happen, because remember, if you're talking about equivalent forms of a particular quadratic, there's only one way that you can write an equivalent form in intercept form. So for another answer to be in pure intercept form, we'd have to have another answer that had exactly what answer choice B has, which is not possible. I suppose there is a chance that on a question maybe they're asking about the coordinates of the vertex, and maybe one of the answers looks like this, I don't know, and another answer looks like this, Well, these are both vertex form. Of course, a question that had these two answers could not say that you are being given equivalent forms. There's no way that this form and this form are equivalent to the same function. Clearly, these are different functions. They have different vertexes. So in a case like this where you saw two answers that had, let's say, the right form, you might have to figure out exactly what are the x and y coordinate at the vertex. But even so, if a question is asking you which of the following forms reveals the vertex, well, you know that you're, at the very least, that your answer has to be in vertex form. The point is that if you at least can memorize the forms, the three forms, standard, vertex, intercept, you'll have a leg up on questions that are asking you to pick a form of a quadratic that reveals certain features of a parabola, of the graph of the quadratic. So that is it for the forms of a quadratic and the information that we can extract from them and what each form reveals in terms of the parabola. As it says at the bottom of the page, it would definitely behoove all students to make sure that they have this information memorized. Of course, be better to understand it first, but also good to just make sure you have it memorized. Many questions will become a lot easier when you are fluent with this information.